Welcome to another deep dive. This time, it's all about the physics behind projectile motion.
Projectile motion.
Yeah, like when you throw a baseball or shoot a basketball or even watch a cannonball in the air.
Oh, so like those classic physics problems. Yeah.
Exactly. And we got a really cool source for this deep dive. It's a page all about simulating projectile motion.
A simulation.
And it's from a website dedicated to open educational resources, so you know it's going to be good.
Sounds interesting.
Yeah, and I think we're going to find some pretty interesting stuff here.
Like what?
Well, first of all, the simulation itself seems really interactive. And second, this website seems like a goldmine for physics resources.
Oh, you mean like besides this projectile motion thing?
Right, like just looking at the website navigation, it's clear they've got tons of stuff on all sorts of physics topics. We're talking about interactive resources, physics, simulations of motion, and then finally we get to this specific simulation.
So it's like buried deep within this website.
Exactly. And the title of the simulation is Projectile Motion with Comparison, which makes me think that's the real focus here, comparing different scenarios,
Yeah, I see that. Like what happens if you change the launch angle or the initial speed or even the object itself?
I think so. Oh, and this simulation was created by someone named John Lowe back in 2017.
2017, huh? And there's something else here that catches my eye. It says it was released under an open license.
Yeah, open licenses are pretty awesome.
Yeah, it means anyone can access it and use it for learning, teaching, even building upon it. It's all about sharing knowledge freely.
I totally agree, and it really speaks to the mission of this website, right?
All right.
Making physics education accessible to everyone.
Mm-hmm.
Okay, but now let's talk about the actual simulation. It's embedded right on the page, and you can play with it as we talk.
Oh, nice. I always love a good interactive element.
Me too. And for those who want to go even deeper, there's also this other resources section with a bunch of links to even more simulations, illustrations, you name it.
It's a bit overwhelming, honestly.
I know, right? Like a Pandora's box of physics knowledge.
Exactly. But hey, maybe we can pick out a few that look particularly interesting and share them with our listeners.
Sounds good to me.
Okay, let's see. Oh, this one looks interesting. Trajectory of a ball with air resistance.
Air resistance, huh? That's something we often ignore in those basic physics problems.
Yeah, for sure. But in reality, it plays a huge role, so it's pretty cool that the simulation lets you see its effects on the path of the projectile.
I'm also seeing one called HTML5 version of projectile motion.
HTML5. So that means it can run on basically any device, right? Phones, tablets, computers.
Exactly. That's really thinking about accessibility. They want everyone to be able to explore these concepts.
Makes sense. Oh, and look at this one. Projectile motion with equations. Sounds pretty hardcore.
Yeah, that one's definitely for the math lovers out there.
Yeah, it seems like it's all about connecting those visual arcs we see to the actual math behind it.
It's like taking a peek under the hood of the simulation.
Exactly. Going beyond just observation and really understanding the why behind the what.
I love that. And speaking of understanding the why, I'm curious about this popular tag section at the bottom of the page. It's got tags like kinematics, electromagnetism, even multiplication and division.
Interesting. It makes you wonder if there are simulations out there that combine like projectile motion with magnetic fields or something crazy like that.
Right. The possibilities seem endless.
Yeah.
But for now, I think we've got a lot to unpack with just this one simulation and all the resources it offers.
Definitely. This is going to be a fun deep dive.
Yeah, it seems like this website really wants to show just how broad a topic physics really is.
Oh, for sure. And that popular tag section really highlights that. It's like you start with something like projectile motion and suddenly you're down a rabbit hole of like electromagnetism and multiplication and division.
It really makes you think, like, what other wild simulations are lurking on this website, right? I'm really curious about those electromagnetism ones.
Yeah, me too. Like, imagine a simulation that combines projectile motion with magnetic fields or something. That would be wild.
Oh, totally. Like visualizing how a charged particle moves through a magnetic field. Actually, I think I've seen something like that before.
Really? Yeah, it's amazing how those seemingly different areas of physics can actually, like, connect and influence each other.
I know, right? We started with just, like, throwing a baseball.
Yeah.
And now we're talking about charged particles in magnetic fields.
It's pretty mind-blowing when you think about it. But I guess that's the beauty of physics, right? It's all connected in some way.
Totally. And it's so cool that, these open educational resources give us the chance to explore all those connections.
Absolutely. Like, you don't need a fancy lab or anything to really delve into these topics anymore. You just need a computer and an internet connection, and you can learn about, like, the trajectory of a cannonball or the movement of a charged particle, all from the comfort of your own home.
It's pretty amazing when you think about it.
Yeah. So, for our listeners out there, what do you think is, like, the biggest takeaway from all of this?
Well, for me, it's definitely a reminder that you don't need a classroom or a textbook to really learn about physics. These interactive simulations and open educational resources make learning so much more engaging and accessible.
Totally agree. It's like learning should be an adventure, not just memorizing facts from a book.
Exactly. And this simulation is a perfect example of that. It's like a playground for physics, letting you experiment and explore all these different concepts in a really hands-on way.
Yeah. And it's not just limited to projectile motion either. This website and others like it offer a whole universe of knowledge just waiting to be discovered.
I know, right? It's kind of overwhelming, but in a good way. It's
Yeah.
like now that we know these resources exist, what do we do with them?
I think the best thing to do is just like dive in, explore, experiment. Don't be afraid to get lost in the world of physics.
Totally. And don't be afraid to, reach out to other people who share your passion for physics. There are so many online communities and forums where you can connect with fellow learners and get help if you're stuck on something.
For sure. It's all about collaboration and like sharing that excitement for learning.
Right, because learning physics doesn't have to be a solo mission.
Exactly. It can be a shared journey of discovery.
Now, I want to get back to this specific simulation for a minute. I'm really curious about the creator, John Lowe. Like, what do you think motivated him to make this?
Well, releasing it under an open license suggests that like accessibility was a big factor for him.
Yeah, for sure. He wanted to make sure everyone could benefit from it.
But beyond that, I wonder if he had a specific problem in mind. Like maybe he was teaching a class and, realized there wasn't a good tool out there for like comparing different projectile motion scenarios.
That's a good point. Or maybe he even had a real-world problem he was trying to solve. Like, imagine if you're an engineer designing a new type of sports equipment, or even working on the trajectory of a spacecraft. Having a tool like this to, visualize and compare different launch parameters could be super valuable.
Totally. It really brings home the practical applications of projectile motion, which can sometimes get lost in the abstract equations and stuff.
I know, right? Sometimes you get so caught up in the theory that you forget that, physics is all around us all the time. But anyway, I think we did a pretty good job of unpacking this projectile motion simulation. We've talked about open educational resources, the creator's motivations, and even the broader connections to other areas of physics.
Yeah, it's been quite a journey. And honestly, we've just scratched the surface. Remember that other resources section with all those links? That's just the tip of the iceberg when it comes to the world of physics simulations and online learning.
I know, it's almost overwhelming, but in the best possible way. It's like we've been given this amazing toolkit for understanding the universe.
Exactly. So what do we do with it?
I say, we use it, we explore, we experiment, we let our curiosity lead the way. I mean, who knows what amazing discoveries we might make.
That's the spirit. Learning should be an adventure, remember?
Absolutely. So to wrap up this deep dive, let's recap some key takeaways. First, we saw how a seemingly simple concept like throwing a baseball can actually open up a whole world of complex physics.
Right. Involving things like launch angles, forces, and even connections to other areas like electromagnetism.
We also learned about the power of open educational resources and how they're making learning more accessible and engaging for everyone.
And of course, we can't forget about the importance of curiosity and exploration.
Absolutely. So as we conclude this deep dive, we want to leave you, our listener, with a final thought-provoking question. If you could design your own projectile motion simulation, what unique features would you include to make it even more interactive and educational?
Would you incorporate real-world scenarios, like allowing users to design the trajectory of a rocket launch or a basketball shot?
Maybe you'd add challenges or puzzles to, encourage critical thinking and problem-solving skills.
Or perhaps you'd even let users design and test their own projectiles, like experimenting with different materials and shapes to see how they affect the flight path.
The possibilities are truly endless. It all comes down to embracing your creativity and using it to, craft a learning experience that's both engaging and insightful.
Yeah, it makes you realize that physics is so much more than just equations and formulas.
It's about understanding the world around us,
Yeah.
right? Why things move the way they do.
Exactly. And this simulation we've been talking about, it's a great example of how Even a complex topic like projectile motion can be made accessible and engaging.
For sure. And it's not just about, like, entertainment either. It's about real learning, real understanding.
Absolutely. So for our listeners who are like maybe feeling inspired to learn more about projectile motion, what would you say is the next step for them? Well, I think the best thing to do is just to keep exploring, keep playing with those simulations, keep asking questions.
Mhm. And, don't be afraid to reach out to others who share your passion for physics. There are so many online communities and forums where you can, like, connect with fellow learners and get help if you need it.
Totally. It's amazing how much you can learn from others who are, also excited about physics.
Okay, so as we wrap up this deep dive, let's leave our listeners with one final challenge. Imagine you've been tasked with creating a brand new projectile motion exhibit for a science museum. What would you include to make it, like, truly captivating and educational for visitors of all ages?
Oh, that's a good one. Well, I think it would have to be interactive, right? Like
Yeah.
maybe a giant display where visitors can launch different objects and see their trajectories in real time.
Oh, I'd love that. Or maybe even like a virtual reality experience where you can actually, like, step into the shoes of a projectile and feel the forces at play.
That would be so cool. And, we could also incorporate some historical context, like show how our understanding of projectile motion has evolved over time from, ancient catapults to modern day rocket science.
Yeah, that would be awesome. It's like reminding people that, physics has been a part of human history for centuries.
Exactly. It's not just some abstract concept. It's something that people have been grappling with and trying to understand for a really long time.
And the cool thing is, it's still relevant today.
Hmm.
Like, we're still using those same principles to, design airplanes and launch satellites and all sorts of amazing things.
Totally. So there you have it, folks. A deep dive into projectile motion that's taken us from a simple website to the vast possibilities of interactive learning and beyond.
We hope you've enjoyed this journey with us and, maybe even learned a thing or two along the way.
And most importantly, we hope we've inspired you to keep exploring the world of physics. It's a fascinating and ever-evolving field, and there's always something new to discover.
So until next time, keep those minds firing and those projectiles flying.